for the portfolio of 2 stocks, and we can extend this to portfolios of more stocks. Okay. Well, one thing that I omitted to say, but that's a direct result of the definitions, is because the return on any asset is also a random variable. Obviously, the expected return of the asset is also defined the same way. The expected value is for a random variable. In other words, the expected return of any risky asset is defined as the probability of the state of nature, of each state of nature, multiplied by the return in that state of nature, and the variance is the probability of the state of nature times the deviation from the expected return square. So, in other words, the definitions of the expected value and the variance of a random variable can be neatly applied to the return on an asset, because the returns are always random variables. Okay. So this is something that it's an immediate consequence of the fact that returns are random variables. And these properties, we have just shown them as a consequence of the properties of the expected value and the variance. Okay, let me just clean it board so that you see what I'm talking about. So we have just shown these two based on the properties that we have demonstrated before. And everything else going forward now will be applied to assets, meaning the instead of random variables going forward, our random variable will be the return on a risky asset. These are properties that we already know. So the expected return of a portfolio of stock A and stock B, and the variance of the portfolio form with 2 assets. And these assets are, if you want to graph them on a XY axis, where the vertical axis is the expected return and the horizontal axis is the standard deviation, which is the square root of the variance. You know that all portfolios that can be created with stocks A and B are on a curve that is known as the opportunity set. We already know that. And this curve, the curvature of this opportunity set depends on what? Depends on the correlation between the 2 assets. The closer to 1 the correlation is, the less curved the opportunity set. The closer to -1 the correlation between the 2 assets is, the more curved the opportunity set is. Okay, we already know these things. So in other words, if you have something with a higher correlation, so the closer to 1 the correlation is, the more to the right the curve is. The closer to -1 the correlation is, the more peaked the curve is. Okay? Now, this is one thing. When the 2 assets are perfectly positively correlated, in other words, when the correlation between the 2 of them is 1, the curve becomes a straight line. And when the 2 assets are perfectly negatively correlated, the curve becomes 2 segments. And that's what we see, what we'll prove next. But before we do that, so remember, this is known as the opportunity set, and it shows what? It maps all the portfolios that can be created with stocks A and B, or with assets A and B. If we are 100% invested in B, that would be at the low end of the curve of the opportunity set. Bless you. If we are 100% invested in stock A, that would be the portfolio invested 100 in A and 0% in B. Anything in between, as we are close to A, that would be a high percentage invested to A, a very low percentage in B. In other words, 99% A, 1% B, 98% A, 2% B, and so on and so forth, as we move along the opportunity set. Of all the portfolios that can be created with stocks A and B, that's something not new for you, I hope. One will have the lowest variance, and that's called the minimum variance portfolio. And for us, this is the minimum variance portfolio. Why? Because no other portfolio on this opportunity set has a lower variance, nothing. If we move to the left of this value, as you can see, the frontier has ended. Okay, so this is known as the minimum variance portfolio. How do we find the minimum variance portfolio? And these are the coordinates of the minimum variance portfolio. So the weight invested in A should be this much, and the weight invested in B should be this much, such that we can get the minimum variance portfolio. Okay, we can replace the sigma A, sigma. Remember, sigma is the notation for the standard deviation. Rho is notation for the correlation, and sigma AB is the sign for the covariance. Okay, so we can replace sigma A times sigma B times the correlation by the covariance, but because that's exactly what the definition of the correlation is. Just to refresh your memory, rho is covariance divided by the product of the standard deviations. So if you multiply the correlation coefficient by the standard deviation of each stock, you get the covariance between the two stocks. Okay? So if you want to know how much to invest in stock A and how much to invest in stock B such that to create the minimum variance portfolio, you apply these formulas. Okay? Yes,
So to find the minimum variance portfolio, you solve for A, you find the sigma squared minus the sigma of both
sigma
sides.
B. So one of the stocks will be stock A, the other one will be stock B. If you want to find out the weight of stock A, you simply take the variance of B, subtract the covariance between the two, and then divide it by the sum of the variances of both stocks, minus 2 times the covariance of stocks A and B.
And why the probability AB, I see, or PAB?
There is no P here.
I just see,
No, this is raw. This is the correlation coefficient. This is the same thing as here. This is not the probability.
Oh.
It looks like a probability, but it's not
Yeah.
the probability. It's rho, the sign, the Greek letter rho,
Oh, rho.
which is the sign for the correlation between the two
Correlation
stocks.
coefficient.
Is
Yeah.
it related to SARP ratio?
Sorry?
Is it related somewhere related to SARP ratio?
Stock.
SARP, SHARP.
Oh, Sharpe ratio.
Uh-huh.
You're talking about the Sharpe ratio? No, Sharpe ratio is a different thing. Has nothing to do with the correlation. Sharpe ratio is the
It measures it.
Sharpe ratio, which just for a particular stock is not a measure for two stocks, and is the excess return, which is the difference between the expected return minus the risk rate divided by the standard deviation. So it has nothing to do with the correlation.
On the sigma A, you have an A1. What's the 1 supposed to designate? Why
What
did
is
you-
that?
You have an A1. You said A1B in a couple places. I'm trying to figure out why.
That's a
A1B.
comma.
Why the sublet? Oh, that's a comma. I'm sorry. Okay, never mind.
Yeah,
Okay.
it's rho AB.
No.
It's a
I got
comma.
it. I got it.
Okay.
Yeah.
Anything else here? So, this is how to find out the minimum variance portfolio. Okay? You just, when you create the minimum variance portfolio, you already know the stock's expected return and the stock's standard deviations, and the correlation or the covariance between the two stocks. If you know them, you can immediately apply these formulas and find out how much you need to invest in A and how much to invest in B, such that to create the minimum variance
Right.
portfolio. Okay?
And that's still for a two-stock portfolio.
That's for a two-stock portfolio. We'll move to an N-stock portfolio in a second. But this shows all the portfolios that you can create with two stocks on. Okay? So far, so good?
And that just assumes, if you pick the minimum variance portfolio, it assumes you're risk averse.
You don't pick it.
I mean.
Oh, you mean as an investor?
Yeah, as
if
an
you invest in-
investor.
Oh, absolutely.
If you wanted more risk, you would accept more standard deviation.
Oh, absolutely. So
Okay.
if you are risk averted, this is the portfolio you invest in. Yes.
Okay.
Now, one more thing I want to say before we move on is this is considered the efficient frontier, and this is considered the inefficient part of the frontier. Why? Because any portfolio you select on the inefficient part, you can always find something that has exactly the same risk, but a higher return. Okay? So let's say P1 and P2.
Okay.
So if you select any portfolio on the inefficient part, you can always find a portfolio on the efficient part of the frontier that will have exactly the same risk, but a higher expected return. So that's the reason you'll never invest in the inefficient part of the frontier. Okay, that's the reason this is called the efficient part, and this is called the inefficient part of the frontier. Okay. The question is, let's say that you are an investor, which portfolio of these two stocks will you invest in? Which portfolio formed with these two stocks will you invest in? And that depends not only on your risk tolerance versus risk taking. It depends on things that we need to define. One is your utility function, and the other one is your indifference curve. And what is the indifference curve? I'll get back to this. So which portfolio on this, and this is for N risky assets, but we'll start with two assets. Let's assume that we have the assets A and C. So which of the portfolios that you can create with assets A and C you will invest in?
T.
Would you invest in the minimum variance portfolio? Would you invest here? Would you invest in others? And obviously, T, if you have this indifference curve. And what is the indifference curve? Well, the indifference curve maps all the combinations between risk and return that would have exactly the same utility function. Now, if you want, different investors have different utilities. What is a utility? What is this? An economic term. It says what?
It would be what gives you the maximum satisfaction.
Exactly. It's a measure of satisfaction. Measure of satisfaction that you get from an economic, what's called an economic act.
Right.
Okay? Meaning you eat a hamburger. Well, that's a satisfaction. So this increases your utility, eating the hamburger, or decreases your utility, depends on what a hamburger means to you. Promotion with no money could be increasing utility for some people and decreasing the utility for others because you get a promotion with no money. So utility means a degree of satisfaction you receive, could be positive or negative, from a certain economic act. Well, we all have different utilities. Things that you can think of this utility as a happiness. There are different things, satisfaction, happiness, and so on. Different things make us satisfied or happy, right? Now, in economic terms, when we talk about the indifference curve, well, everything along this line would be a combination of risk and return for which the utility would be exactly the same. In other words, you can take a little more risk, but the return should be higher, and you are still you have the same utility. However, as you move towards the left of the graph, your utility increases, okay? And you are absolutely right when you said, if this is you, this is your indifference curve, then in order to maximize your utility, you move to the left. And what would be the portfolio created with A and B that you would select? The one that will be tangent to, the one that is selected such that your indifference curve will be tangent to the opportunity set. Okay? Now, you may have a different utility, or different indifference curve. Say that your indifference curve is this way. Will your portfolio be the same as, let's say, investor one? This was investor one, this would be investor two. Absolutely not. Because you still, all investors want to maximize their utility. So in other words, you will move your indifference curve until it becomes tangent to the opportunity set. So which portfolio on the efficient set you select depends on your indifference curve, and it depends on your utility, okay? In other words, the portfolio is not unique to all investors because we all have different utility functions. Make sense? And this is the reasoning for a portfolio made of two stocks, but it can be extended for a portfolio made of many stocks. It's exactly the same reasoning. So you'll always select the portfolio on the efficient curve, assuming there is no risk-free rate. That's the state we're in. So assuming there is no risk-free rate, you'll always select the stock on the efficient frontier, such that your indifference curve will be tangent to the frontier, okay? And these portfolios are not unique. In other words, different investors will select different portfolios, okay? And this is in the absence of the risk-free rate. Yes, Ed?
If your indifference curve is lower, then where would your tangent line be?
What do you mean
So
lower?
you went to the right, you showed a few indifference curves to the right.
You still, in order to maximize, you will still move it to the left
Oh, you-
until it becomes tangent.
I got it, you always
Yeah,
have to, you're
you
always veering
always-
toward the tangent.
The goal of every investor is to increase
Right,
the utility.
okay,
So in order to increase the utility, you always move to the left.
right.
Now, definitely it will be a tangency point regardless of
So
the
you
shape of
adjust
your.
your basket until you
Yeah,
get to the left.
yes,
I got it.
yeah, okay? Now, what about if the risk-free rate exists? And that's the next thing we do. So what would be the portfolio? If the risk-free rate exists, what would be the portfolio that you select in this case? You still have the efficient, the opportunity set is still from A to C. Which, in this case, which portfolio on the opportunity set will you select?
Where the risk-free rate is tangent. to
When the risk-free rate exists.
It's tangent to the,
So you'll always select, you're absolutely right, Ed, you'll always select a portfolio that is set on the line tangent to the opportunity set, starting from the risk-free rate. And this is known as the capital market line.
capping.
Not CAPM. It's capital market line. CAPM is the model itself. This is just a line. So yes, Anthony.
It goes to your commentary about lawsuits. That's presumptively a lawsuit, if you invest below it, that the broker would lose.
To invest below what?
The risk-free line.
Oh, you mean here, somewhere here? Yes. So you'll never invest below, and we'll see that this is known as the two-fund separation principle. You'll always invest on the capital market line. Why? Because first of all, you want to have to be able to borrow and lend at the risk-free rate, and you also want to invest in the what's called the market portfolio. All investors, regardless of their risk tolerance, want to invest in the market portfolio, and therefore they're always invest in a portfolio that has a little bit of the risk-free rate and a little bit of the market and the rest of the market portfolio. If if you are a risk averter, you'll be closer to the risk-free rate because you don't want to take too much risk of investing in the market portfolio. So the more risk avert you are, the more to the left your portfolio will be. The more risk taker you are, more to the right your portfolio will be. And you say, well, why is it outside the range between the risk rate and the market portfolio? How can you have a portfolio that has a return above the return on the market portfolio? And the answer is you borrow money at the risk-free rate and invest it in the market portfolio. So anytime you are to the right of M, it means that you have borrowed money. In other words, you purchase the market portfolio on margin. Anything you are below, if you are between the risk-free rate and the market portfolio, it means that you are using your own money, you invest in both. The risk-free rate could be a zero coupon bond, could be anything that is risk-free plus the market portfolio, okay? So the portfolio you select is still not unique, but what's unique is that all investors want a little bit of the risk-free asset, which is represented by the risk-free rate, and a little bit of the market portfolio. And this is known as the, once again, is the two-fund separation principle, because these are known as the two funds. The risk-free asset is one fund, and the market portfolio is the other fund, okay? Yes.
And how do you contrast that with the SML then, the security market line?
Well, that's a different thing. Security market line is CAPM. Let's wait until then. It's the relationship between risk and return. This doesn't have anything with the risk and
No
return
risk
yet.
yet.
Okay? It just shows where everybody wants to be. What is the portfolio that everybody wants to hold? And it's not a unique portfolio, it's just a unique combination of portfolios. So everybody wants to have a little bit of the risk-free asset and a little bit of the market return. Yes, Anthony.
I understood CML and the SML, the difference is the calculation of one standard deviation and one